Welcome back. Connecting to the last previous video, that is characteristics of a laser. The important 4 characteristics of a laser is coherence. The next one is monochromaticity. Third one is the directionality, and the fourth one is the intensity or brightness. Right? So, connecting to those characteristics of a laser, we will discuss some important conditions for a laser. Conditions for laser. There are 2 important conditions for a laser. So we'll just check it out. What are those important conditions? Let me recall some of the important points in the Einstein coefficients. And you just review the video of the Einstein's coefficient derivation. And so from Einstein coefficients, you just refer your assignment or the video, the lecture 3, that is Einstein coefficients. From Einstein coefficients, we have an important equation, that is stimulated emission rate. Stimulated emission rate is equal to N2, so rho nu, so B21, where B21 is an Einstein constant. If you refer, this is equation 3 in Einstein coefficients. And also we are having the stimulated absorption rate, and that is N1 rho nu B12. So this is equation 1, and this is equation 3 in the derivation of Einstein coefficients. You just recall or you just refer your assignment, right? Then I will take a ratio between these 2 parameters. So what happens here? So therefore I will write it as a stimulated emission rate by stimulated absorption and rate. If I take therefore N2 rho nu B21 by N1 rho nu B12. Right. So if you look at these parameters, rho nu will get cancelled, and from Einstein equations, that is equation X and equation that is Einstein equations X and Y. That is what I will say. You just refer the Einstein coefficients derivation. You will find out the equations X and Y, and I will use only equation Y. That is B21 by B12 is equal to 1. Therefore, B21 is equal to B12. Right? So then this parameter becomes, then this ratio synchronizes like this. This stimulated emission rate by stimulated absorption rate is equal to N2 by N1, and here B21 and B12 are equal. Therefore this ratio is nothing but equal. Therefore then they will equal to 1, and as a result and from this, if I say that in equilibrium or in a thermal equilibrium, means under equilibrium state, here what N1 represents? N1 represents the number of atoms in the ground energy level, and N2 represents the number of atoms in higher energy level. But in thermal equilibrium state, definitely N1 will be greater than N2. Always the important condition in thermal equilibrium is N1 will be greater than N2. And as a result, if I take the ratio of N2 by N1, then this ratio will be less than 1, obviously. Therefore, a stimulated emission rate by a stimulated absorption rate will be less than 1, and I will take the parameter here. If you take a stimulated emission rate is less than a stimulated absorption rate. If you look at this important conclusion what we had drawn is, in thermal equilibrium, the stimulated absorption rate is a dominating stimulated emission rate, which is not a feasible condition in order to get the laser, because for a laser, what is the parameter? The dominating parameter is stimulated emission rate must dominate. But if you look at the condition, what we had concluded is the absorption rate is dominating. So in thermal equilibrium, this is stimulated absorption, SA, that is stimulated absorption rate, is dominating. But who must dominate? Stimulated emission rate must dominate. So therefore, why this condition is acquired? The condition is acquired due to this condition, right? That is a N1 greater than a N2. Therefore, here I use a word called as N1 is the number of atoms in the ground energy level, N2 number of atoms in higher energy level. That I'll name it in the another way, population of atoms in energy level E1 is greater than the population of atoms in higher energy level E2. So due to this condition, that is the population in ground energy level is greater than the population in a higher energy level. So I am naming this N1 as a new term called as a population. So therefore, due to this population, the condition we have acquired is, that is the stimulated absorption rate is dominating, is greater than stimulated emission rate. But we require the domination of stimulated emission. As a result, we will be getting the output as laser. So for this to dominate, that is a stimulated absorption rate must dominate the stimulated stimulated emission rate must dominate a stimulated absorption rate. Therefore, this condition must be reversed. This condition must be inverted. This condition must be inverted, or this condition must take place in an inversion process. Hence, I'll say this as the inversion of this condition is population inversion. Therefore, by somehow you make N1 greater than that is N2 greater than N1. So I'll just twisted the equation. I had taken the inverse equation of this condition, inverse condition of this condition, that is you make by somehow, you do any magic or you do any logic or you do any mechanism or any process such that you increase the population in higher energy level than the population in the ground energy level. If this is done, therefore I had inverted. Therefore, as I had inverted, I had written as inversion. What I had inverted? The number, the population I had inverted. Hence the name, I will make it as inversion, population inversion. If population inversion is done, then automatically stimulated emission dominates. Therefore, the condition, this condition also gets inverted, and the stimulated emission is dominating. Then we will get the laser. Because in the laser term, SE, stimulated emission, is the important process to occur. Therefore, for this process to occur, we have to make the thermal equilibrium condition state as inversion. Therefore, that inversion is named as population inversion. Therefore, from this discussion, from this small discussion or conclusion, what I will write is the conditions for a laser is the important condition is you have to create a population inversion. Population inversion. That is, you make the number of atoms in higher energy level more than the number of atoms in the lower energy less. That is, the population of higher energy state must be greater than the population of atoms in the lower energy state. If this is done, if this condition is done, then we will be getting a stimulated emission, and if this stimulated emission is occur, then we can conclude as laser. And another important condition is you make or you increase the energy of a density of photons, density of interacting photons. Interacting photons. That is what I'll say. If we are using rho nu is the density, this rho nu's energy, that is rho nu, that is the density of photons, energy must be increased for the better interaction, because these photons are these photons will interact with the atoms and automatically the stimulated emission occurs. This energy, the supplying energy, that is h nu energy, must be increased. That is the density of interacting photons must be increased, and as it is these two conditions are these two conditions are increased are attained, then this laser will be an efficient laser. The output of the laser will be very efficient laser, so which can be used for many applicative purposes in science and technology, right? And the conditions for a laser are the two conditions, that is population inversion and increasing the energy of the stimulating photons or interacting photons. And now we'll discuss what is population inversion. So as I said that a new term population is introduced. The population here means the population of atoms, that is the number of atoms is termed as population. So population inversion. Right. Population inversion. The population inversion is an important condition. For the amplification of light. If you look at, we are attaining the word light amplification, right? So that is an important condition for the amplification of light by non-equilibrium. Equilibrium means thermal equilibrium, where N1 is dominating. In equilibrium state, N1 will be greater than N2. We doesn't require that condition. We require N2 greater than N1. So this condition is called as non-equilibrium condition. We doesn't require that condition. We require this condition only. So that is by non-equilibrium distribution. Non-equilibrium distribution of atoms in various energy levels. If the atoms are inverted, that is making the higher energy level atoms number more than lower energy level atoms is a non-equilibrium condition by the distribution of atoms in various levels. When we utter the word the distribution of atoms in various energy level, and this was guided by a Boltzmann distribution equation for the atoms in various energy levels, So various energy levels, and that equation is given as Ni is equal to N naught exponential minus Ei by kT, which you are very familiar with this equation, where T is the absolute temperature, and K is the Boltzmann constant, whose value is 1.38 into 10 power minus 23 joule per Kelvin. Okay, right, and where E is the energy and N naught is the initial number, and where Ni is the instantaneous number of atoms in various energy levels in an arbitrary value, where if I take where I is equal to 1, 2, 3, so on. So let us consider the number of atoms in a lower energy level. Therefore, where I have taken I is equal to 1, N1 is equal to N naught exponential minus E1 by kT, where I replaced I with 1, and similarly N2 is equal to N naught exponential minus E2 by kT. Simply I will take a ratio. Simply consider the ratio. Consider the ratio of the two equations, that is N2 by N1 is equal to, so N0 will be getting cancelled, therefore exponential. So here already minus E2 will be there, and this lower exponent terms reaches the numerator, and here automatically plus E1 will be there. If I take a minus term as a common, then this is the equation. Alright. by kT, right? So this is how I had synchronized the equation. So you can check with the as I'm removing some of the steps, intermediate steps. If you work it out, this will be the final equation, that is n2 greater than n1. Now closely look at that exponent term. You closely look at that exponent term. The exponent term is having a negative term, and the maximum value of this exponent term is highly or most probably reaches 1. Okay, right. Then in this situation, I will write therefore n2 is equal to n1, and I had cross multiplied, and this exponent term, therefore exponent of minus e2 minus e1 by kt under brackets. Therefore, this exponent term reaches when kt greater than, so e2 minus e1 value, then this exponent term value reaches 1. And in that situation, n2 may be equal to n1, but it cannot overcome n0. So here you have to apply mathematics here. So there may be chances of n2 slightly or most probably may be equal to 1, but never overtake n1. So by this conclusion, I will say that here it is dominating, n1 is dominating n2. That is the number of atoms in higher energy level, lower energy level is greater than the number of atoms in higher energy level. And as I said that this is not an important, this is not the condition for a laser. This is not the condition for laser. So the condition for by, so here Albert Einstein says that by somehow you closely look at the word what I had written. By somehow means you do any process, you do any mechanism, you do any event or effect such that by somehow make the condition, that is n2 greater than n1, that is make the number of atoms large in higher energy level than the number of atoms in lower energy level. So this making the number of atoms in higher energy, making the number of atoms in a higher energy level, that is n2 greater than the number of atoms in a lower energy level, that is n1 is known as that condition, making the number of atoms in higher energy level greater than the number of atoms in lower energy level. This is known as the population inversion. This is the condition for, so that is n2 greater. This is known as a population inversion. So where I had inverted the condition, when this population inversion is attained, then automatically stimulated emission occurs, and as a result we are attaining the word laser. So how this population inversion is attained? What is the process? I had said that by some technique or by some effect or by some mechanism or some by process or by magic or logic. I am saying that by somehow you make it. So how we can make it? So this can be done, this population inversion can be occurred by a process known as pumping. Yes, what is that word pumping means? We'll look into the later topic. So let me review what is the population inversion condition. So the population inversion condition is an important condition for the amplification of light. So amplification of light by the not equilibrium distribution. Equilibrium distribution means lower level will be very high and higher level will be very less. Non-equilibrium condition means inverting, that is non-equilibrium distribution of atoms, that is making the atoms higher energy, making the number of atoms large in higher energy level. So therefore that non-equilibrium distribution of atoms was guided by Boltzmann distribution law or Boltzmann distribution equation, where it is given as Ni is equal to N0 exponential something, where T is the absolute temperature and K is the Boltzmann constant. And with this equation, I had considered the number of atoms in a lower energy level. So lower energy level atoms. And also considered the higher higher energy level atoms. So these are the two equations. N1, number of atoms in lower energy level, N2, number of atoms in higher energy level. So simply I just calculated the ratio, what happens for the discussion. So N2 by N1, where N2 is equal to N1. If I look at that, the exponent term, this exponent term hardly becomes 1. Hardly becomes the maximum possible value of exponent term is 1, but it cannot exceed, that is N2 cannot exceed N1, means N2 cannot exceed N1 means the condition is N1 greater than N2. So which is not a required condition for the laser. So, but in thermal equilibrium, this is the condition. We will get the solid in this situation only. That is the number of atoms in the ground level will be very high because of to attain stability. But with this material we cannot bring the laser. So then Albert Einstein proposed that you do some mechanism by somehow you make N2, that is the number of atoms in higher energy level, large than N1. So making this process, making the condition inverted, or opposite or vice versa is known as a population inversion. And this population inversion is can be attained by a process named as a pumping, which we will be looking right now. So now I will try to write the diagram or try to. So population inversion can be defined also like this. It is a process. It is a process, or it's a mechanism, or it's a condition by which the population of atoms, that is making N2, is larger or greater than population of atoms, that is N1 in a lower energy level. Let everybody follow this definition. So population inversion is a process or a mechanism, or it's an important condition by which the population of atoms in a higher energy level is greater than the population of atoms in the lower energy level. So if this condition is acquired, if for example N2 greater than is acquired, and then we are ready to produce a laser. For this condition to make, or this one condition to attain, so there is a process known as pumping. Then what is the word pumping means? So pumping is a process to excite lower energy atoms to higher energy level, right? So it is a process where I am trying to excite the lower energy atoms to higher energy level atoms, right? Let me go for a rough diagram where you will feel very feasible. So generally in thermal equilibrium, thermal equilibrium, we will be having like this. If you look at, so this is a lower energy level where N1 is very large, and this is the higher energy level where N2 is very less. If you look at this is the condition. So this condition doesn't give stress to the laser, because for the stimulated absorption, for the stimulated emission to occur, the atoms number must be very large in the higher energy level. So this is not a condition. So now I will try to pump the lower level atoms. I will pump. So how this pumping can be done? Supplying some external energy. So when I supply some external energy to the ground level atoms, all these atoms will be excited to higher energy level atoms. So therefore, so this how it reaches to excited level atom. So I'm making the atoms to jump to higher energy level atoms. So this is what condition, what I'll write it as a non-equilibrium condition. So where after pumping is done, now the atoms will be raised to higher energy level, that is a higher energy level. Now here if you look at, that is a N2 is large, and now this N1 is becoming very less. If you look at the condition, that is N1 is very low and N2 is dominating, therefore N2 is becoming greater than N1, which is an important condition for a laser. That is, but when the atoms are very high in the higher energy level, then there is a chance of a stimulated emission to occur. Here, when a photon interacts with this higher energy level atom, the atoms jump to the ground, de-excite to the ground energy level, and there, here in this situation, this process is known as a stimulated emission. When this word SE, stimulated emission, is occur, then we will be getting laser. Therefore, this is the important condition for this, and this condition can be acquired by a process known as pumping, right? And this pumping, so it's highly impossible to imagine pumping because the word appears like pumping means how this can be pumped. So if I write the types of pumping, the first type is optical pumping, where we can supply the light energy. If we supply the light energy, then the atoms will be raised or excited to higher energy level. Therefore, this is known as optical pumping. And there is another source of energy called as electric discharge. And if I supply some voltage to one plate, that is anode or cathode, then there will be a discharge in the gas, and there the atoms will be raised to higher energy level atom. And the third one is injection current. This is also where the current also pumps the lower energy atoms to higher energy level atoms, and this is one form of energy. Electric discharge is one form of, that is voltage is one form of energy, and here light energy. And there is also a chemical reaction. All these are the types of pumping. So these are the types of pumping where the lower energy atoms can be pumped. So if I supply optical energy to the ground level atoms, all will be pumped to higher energy level. If I supply some voltage, electric discharge, then all the atoms will be raised to higher energy level. If I supply some injection current or current to these ground level atoms, all will be pumped to higher energy level. If I supply some chemical reaction, if I use some chemical energy where it is an exothermic reaction, there are two types of reactions, endothermic reaction and exothermic reaction. In the exothermic reaction, when this exothermic reaction liberates some energy, and due to that energy, the atoms will be raised to higher energy level atoms. And when the atoms are pumped to, or the population is increasing in the higher energy level, then N2 becomes greater than N1, and this is the condition of population inversion, which will be getting stimulated emission, and thus will be getting laser.